Hey mathematicians, today we're going to talk about geometry proportions, proportions that are on shapes. Don't want to waste your time. We'll go ahead and get started. So we want to solve geometry problems using proportions. That's the whole point of learning proportions again. And we can set up proportions by matching up different sides in a proportions problem. So this problem says, first of all, this is a new symbol. This symbol without the equal sign just means similar. And similar means two shapes that are the same shape but different sizes. And that's why we need proportions. We want to find ij, which is here. We're going to call that x. And we want to find the length of ij. Now we know that, so I want to find ij. If I use the letters, I know that that matches up with VW. So x is ij, VW is 12. Well, then I also know that I need to use the other number from each shape. And 1 matches up with 6. 1 is hi, which matches up with xb. And I now have a proportion I can cross multiply and solve. I have to match up based on the order of the letters in this statement if I can't tell based on the way the shape is turned. So we're going to cross multiply. We're going to have 6x equals 12. Divide by 6. X equals 2, which means the length of ij is 2. So not too terrible. Just want to make sure we know how to match up the sides. The more sides a shape has, the harder it can be to tell which ones match up with each other. We want to use the order of the letters to figure out which sides match up with each other. And so we have these two quadrilaterals, UVWX, JIHK. We want to find HK, which we're going to call X, and JK, which we're going to call Y. We got to do them separately from each other. Based on the order of the letters, we've got HK, which is the last two letters. So it must match up with WX. HK we've called X. WX is 6. And then this one is the only number on that shape. So IH is 30. That's the middle two letters. So we must match up with VW, which in this case is 5. So now we have a proportion to solve. We will cross multiply. 5 times x equals 6 times 30, which is 180. And then we will divide by 5. X equals 36. For JK is the first letter and the last letter of its quadrilateral. So it must match UX. JK is Y, UX is 4. And the good news is we can actually use the 30 over 5 again. So we have 5y equals 120. We're going to divide by 5 so that y equals 24. X equals 36, y equals 24, so 36 here, 24 here, and now we know the missing sides that we were asked to find. On this problem, the text didn't copy over. We're asking, are the triangles similar? And for me, when they're all mashed up like that, it makes sense to me to redraw them so they're two different triangles. So I still have this one with 16 and 25, and then I have a much larger one with 88 as its full length, and then actually 25 plus 107 as its length. So if I'm matching this up to make a proportion to see if the ratios are the same, I don't actually need to make a proportion. I can just reduce the ratios. 16 matches 88. And we learned how to reduce the ratios in lesson 6.1. The largest number both of these can be divided by is 8. So I get the ratio 2/11. If the ratio between the other two sides is also 2/11, then they're similar. If the ratio is not 2/11, they're not similar. And when I put 25 over 132, I realize there is nothing that can reduce. This one is already reduced. These are different ratios. So they're not similar triangles. They are not the same. So that's, if you're asked, are they similar, you would find the ratios and then test it. Our last two problems are scale drawing problems. We learned on Monday that we wanted to convert to the same units, but not for this. This is different. These are proportion problems. We have 6 centimeters on her blueprint for this house. And this is not the whole house, or it would be much larger. And every 6 centimeters on the drawing is 12 feet in the house, which we know we can reduce by 6. Again, normally we would change them to the same units. We are not doing that for this problem because it is a scale drawing problem. If we reduce, every centimeter on the blueprint is 2 feet in real life. And so this one's actually, we could set up a proportion for every one of them. But to me, it makes more sense to say, oh, we double the number of centimeters and change it to feet. So 10 times 2 is 20, and now it's in feet. 9 times 2 is 18 in feet. 7 times 2 is 14 feet. 8 times 2 is 16 feet. If this had not been 1 to 2, we would have to set up a proportion for every single one of these. But it's not one of those problems, so we actually are just able to double all the dimensions and change them to feet. For Max, though, Max's scale drawing, we know that on his drawing, Salt Lake City and Arizona are 21 centimeters apart. We also know that 7 centimeters, and I make sure that the centimeters match up with each other. 7 centimeters is equal to 250 kilometers. That means we want to know how much does the 21 equal in real life, which is x. So again, we would set up a fraction with the scale, 7 to 250. And then we would set up another fraction with the number they give us, with the units matched up. And then x is going to be the last thing that you have. So let's all cross multiply. 7x equals 5,250. We divide by 7 and get 750 kilometers. That is it. That's all you have to do. There are 2 scale factor problems on your assignment, and the rest are problems like the first 2. Good luck. I will see you all in the next video, and please, as always, Canvas message me if you have any questions at all. Thanks.